So yes, we're going to go up here to File in the menu here for Jupyter Lab, go to New, and then you can go to Text File here to create a new text file. If you click on that, you'll see you're taken to this empty file here that has nothing in it. So it's, yes, as Foucault was noting in the chat, you can see how to create the text file also in the comments in chat. So our empty text file, well, currently doesn't have anything in it. And I'm just going to jump back to the tab with our functions lesson in it and scroll down here. And let's copy and paste this piece here. We have a definition of our Celsius to far function that we had from before. I'm just going to copy that text, go back to my file here and paste this in. So now we have our definition of a Celsius to far function that we had used previously in our text file. So this is basically a regular old text file, nothing special. Now, you can see at the moment, the name of the file here is untitled.txt. Well, we don't really want to use that name. So we can go here to either File and rename file this way, or if you prefer, you can right-click on the tab here in the bar and choose rename file that way. But we're going to rename our file in here. And so you should get this little dialog box that pops up. And you can select everything that's there and hit delete. And we're going to call this file temp_converter.py. So the important thing here in renaming this is not only to change the name of the file, but also to make sure the file extension is .py. That will identify this as a Python script file. So when I click to rename it, you can see now the name up here in the tab has changed. So if your name didn't change the way you expected, of course, you can right click and go back to rename the file again. But now you can also see that because it's recognized as a Python script file, we also get some syntax highlighting here. So we can see our statements showing up in green, name of the function in blue, and things like that. Okay, so by renaming it, we have also saved the file, but if you're just being paranoid, you can also just go to File and do Save Python File again to make sure that you have saved a copy of it. And that is our first little script file where all we do is define one function. Now we can go on to the next step of using this script file and maybe explaining a little bit about like why you would even want to bother with making this kind of script file in just a second. But before we do that, in the lesson, if you scroll down a bit further back in the tab where your functions Jupyter Notebook is open, you would scroll down a little bit further, you'll see that we also have some definitions here for our Kelvins to far and our Kelvins to Celsius functions that we had defined earlier. And I'm just going to copy those as well over here to my temp converter file and paste them in here. So I'm just copying what is listed here in the section about saving functions in a script file, copying those functions over here to my temp_converter.py. And you can press Control S or Command S if you're a Mac user, or go to File, Save Python File to save the changes. But we want to make sure that you save them before continuing on. So what we have at this point is our script file with 3 functions defined in it. And our next step is actually to try to use these functions from the script file. The whole idea of why we're even doing this is that oftentimes if you have a bunch of functions defined, you could think of them as your own kind of personal library of functions. If you've got functions you've created that you use regularly, you can define those functions and put them all in a script file, and it makes it easy to then load them in from the script file rather than having to include them in one of your Jupyter notebooks, and you can load them in and use them from that point. So now we've got our temp converter still open, but I'm going to jump back here to the functions lesson plan and scroll down a little bit further to the section about calling functions from a script file. If any of this gets too fast, or you're out of sync between what you're doing and what I'm talking about, just say something in chat, please. So here, the first thing we need to do in order to load our script file in to be able to use it is figure out where we are in our current working directory in this Jupyter notebook, so that when we try to load the file, we can make sure we're able to find it to load this. The way to figure out what directory the Jupyter notebook is currently working in is to run a command here that's %ls. ls will tell us the list of files in the current directory, and I do %ls here, and I see functions.ipynb, the modules lesson, and here is our tempconverter.py. Most likely, if you're following along and doing this the same way that we are, you'll see also a tempconverter.py file when you run this magic command, %ls. And if you see this tempconverter.py, everything is okay and you're good to continue. If you're working, for instance, in Binder, it's possible you somehow wouldn't see it, although you probably should. But it's possible you might see something that looks like the output that's shown here, where you can see the lesson directories and README files. So if that's what you see, then you can do this command %cd and then L4 to change the working directory into the working directory for lesson number 4. And for instance, on the CSD notebooks, if you somehow did %ls and saw that you were sitting in the main base directory, you could then do %cd notebooks/L4 to change directories in a Python cell. So you can do that, for instance, just by running that same thing in the Python cell here, or you can add a cell underneath here if you wanted to, and then change directories that way. If you're having problems with this and you're not seeing that when you do this %ls, you don't see your tempconverter.py, feel free to say something in chat by putting a red X or the no button, and that will tell us that you need some assistance, and perhaps Vocal can check and see how things are going. So yes, checking just to confirm that we're in the right directory. Again, if we run %ls in this cell here, I see my tempconverter.py, which means I should be all set to go. Now, what we're going to do is now import a function from our script file that we just generated. Our script file is essentially what Vocal will talk about in the next lesson. At this point, it's essentially a module. It's a group of Python functions that are in a file that we can read and use functions from. We can import our script function just as a single function. We could pull one out using the format below. So we could say from, and then we give the name of the module. So in this case, it's temp converter. We don't need to include the .py. That's not part of this syntax. So it should just be the name of the file without the .py. Import Celsius to Celsius to far, F-A-H-R. I run this, and what it does is it goes into my tempconverter.py file. It finds a function here called Celsius to far, and it brings that in to be defined locally in this Jupyter notebook where I'm working now. And just as we could do earlier with our Celsius to far function that now has been imported, we could do something like print out that the freezing point of water in Fahrenheit is, and use our Celsius to far function with a temperature of 0 degrees. This is essentially exactly what we had done before, but now we're reading our function definition out of our temp converter file and using it from there. And if I run that, I should get the output that the freezing point of water in Fahrenheit is 32 degrees. Yes, that's what I get. So it appears that that is working properly. Now, if you wanted to import more than one function from a script file where you've defined them, you can also do from whatever the name of the script file is, import function 1, comma, function 2, comma, function 3, whatever. You could list multiple functions that way. If you're going to import more than about 3, it's probably better to just import some piece or the whole group of functions. But you can do things, if you need a function here or there out of a bigger library, you can do that. It does look like there's one red X, so hopefully, Volko, you're able to check in with Mika about the issue. Yeah, so then here, an alternative to importing functions in the way that we have to say like this, from this import blah, 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 is to import all of the functions together. The reason that this from some module or from some script file import a function name can be problematic is that if we, as we already did actually in this case, if we had defined a function called Celsius to far elsewhere in the code, and then we import this, it's going to clobber and overwrite or overrule the value that was defined in the function earlier. So it will replace our earlier definition of Celsius to far with the one that's come from temp converter. That's not always a problem, but it's something to be aware of. And that's the reason why it might be easier to import something from temp converter, or actually import the entire temp converter group of functions in a different way. And that is here, we can do an import, again, temp converter. And we're going to call it as TC. So we're going to bring in all of the functions from temp converter, from our script file, and call them TC. This is basically similar to like what happens when you import math, and you can see you can do math.sign. All we're doing is we're renaming temp converter to be TC just because it's shorter to type that in if we want to use those functions. But when I do this import temp converter as TC, I read in the entire set of functions from the temp converter and from that script file, and then I'm able to use individual functions like so. So here I could say that the freezing point of water in degrees Fahrenheit, and again is, now we're going to use the function from our temp converter by doing tc dot and then the name of the function. So this tc dot indicates that the function is part of this temp converter script file, tc.celsius to far with a temperature of 0. And if I run that, I can again see the freezing point of water in degrees Fahrenheit is 32. The key thing here is that I'm now putting tc dot in front of the name of the function to indicate that I want to use the Celsius to far function from this temp converter library that I've just read in. Now, if I just copy this, paste it down here, I could also say that, for instance, I guess copying didn't really make that much help, but I could say that absolute 0 in degrees Celsius is, and here then I could replace my function from Celsius to far to be kelvins to Celsius. And again, if I put in 0 kelvins, that's absolute 0, and I run this and get the expected output. And similarly, you can do the same thing as it's shown on the course page for converting temperatures from kelvins to Fahrenheit, but it's essentially the same thing that you do. TC dot, and then the name of the function that is coming from the script file you have just written. So just, yeah, to recap here, what we've done is we've created a text file here that's a Python script file. The way that we've identified it as a Python script file is with the .py file extension. The name of the file here is tempconverter.py, and in here we just have these three functions that are defined. In order to use those functions, then we've basically read in from this tempconverter.py either an individual function by doing from this file import something, or imported the entire thing as a group of functions, or all the functions from this temp converter script. And here in this case, renaming it to be TC just for the sake of making it shorter to type in and easier to use. You'll see a lot of these kind of things for common Python libraries that we'll be using. So there's a bit more here on the course page about a temperature calculator. I'm not going to go through this part of the lesson, but you can read through there if you would like, and also play around with creating a temperature calculator that would allow you to specify which units you want to convert from or to or whatever. At this point, maybe I'll ask, are there any questions? Okay, if not, I think I will, should I show the docstring? Yeah, we could do one example of a docstring. We'll talk about this. It's covered in more detail in the, good coding practice for this week. But yeah, we haven't seen anything yet about a docstring, so let's show just an example here. So we have our definition in our script file of this Celsius to Fahrenheit function. And one thing that is a good practice in coding in Python is to include something called a docstring that's essentially some text that describes what the function does. And I'm going to show a very simple example here because there's more details about this in the good coding practice for this week. But a docstring is typically indicated, it would be directly after the definition of the function, the first line after the function is defined, and it will be text enclosed in double quotation marks. You can use single quotation marks too, but stylistically, it's recommended to use the double quotation marks for some reason. Then you should have some text here that says what this function does. Here, we have a function that converts Celsius temperatures to Fahrenheit. As a single line, very simple description of what our function does, that's all we need. Probably if we want to document this properly, we should also include what the parameters are that are given and what the value is that gets returned. But for the sake of simplicity here, we're just going to have a single line where this text now explains to someone who looks at this function what the function does. It might be rather obvious to you looking at it now, but of course with a more complicated function or more, a complicated longer function, it might not be so obvious what it does. So I've now added this docstring to our Celsius to Fahrenheit function. I'm going to save the file, and I've just saved that. And I'm going to go back here. One of the unfortunate things is that when you want to reload, like if you've updated a function definition and you want to reload that in Jupyter Notebooks, it's best to actually kill the kernel that you have running and restart it, because if you reload it, it doesn't actually nicely replace what's already been read in earlier. So I'm just going to go here to kernel and just do a restart kernel, which tells me that I'm going to lose all my variables that have already been defined. I'm okay with accepting that just for the sake of demonstration. So back here, we had this example here of from temp converter, import Celsius to Far. I'm just going to run this cell again because our temp converter Python script already exists. We can import our Celsius to Far function here. And on the line underneath here, I'm just going to say why you want to include a docstring. I mean, there's several reasons, but among them is that let's say that someone had this in their code, this from temp converter import Celsius to Far. They might say, what the heck is this Celsius to Far thing? And they could run help on the Celsius def_var name of the function that you've defined. If I do that, then I see here help on function Celsius def_var in module temp converter. Already some useful information there. It then shows what the call to the function looks like. And now you can see here our docstring for this function that says converts Celsius temperatures to Fahrenheit. This documentation can be really, really useful if you start to have many different functions that you're working with. And it's a good habit to get into adding a docstring to a function when you create them just in general. So that's a very quick docstring example. And yes, at this point, if there aren't any questions, I think what I will do is I'll stop sharing my screen and turn things over to Vuoko, who will talk to you now a little bit maybe about Python modules.
All right. Yes, thanks, Dave. I hope my screen is not too blurry. So continuing in lesson 4, in here under loading and using modules. So I'll kind of give a bit broader overview of what then these little Python script files combined to bigger packages can do for us, as there are many openly available modules and packages online readily available that we can then use, import the modules from those packages and so on. So what is a Python module? Well, for example, this temp converter.py that you just created is an example of a simple module. So module has some definitions of functions and variables that are often designed to do a specific task. Like here, we were converting temperatures. Then we might talk about Python packages. So packages are basically collections of modules or sub-packages that then serve kind of a bigger purpose, or do they're kind of larger entities comprised of then smaller pieces that are then these actual Python script files with function definitions and variables. Then there's the third word, libraries. So these modules, packages, and libraries are sometimes used as synonyms, but then a library is then even more bigger collection of Python packages and modules. So you might then, when Googling for help, you might Google for matplotlib library or other Python packages. And then these separate libraries and packages have their own documentation online. So we'll do here a little bit of recapping, refresh your memory of the modules and packages that are already familiar to you, and maybe increase a bit your understanding on how these modules actually technically are loaded and how we can import functions from the modules and so on. I'll switch back to CSC notebooks. Under lesson 4, there's this Jupyter notebook called modules to show some examples. Oops. Getting a bit blurry. Okay, maybe it's the CSC notebooks. Let's see. Is it any better? Quite blurry. We could also do so that if Dave shares his screen and I explain, or then Dave can explain. I apologize for the poor internet connection from home. What do you think, Dave?
Yeah, let's try it.
Yeah.
This will be very interesting experiment as like kind of a, see how well I can follow Vuoko's instructions.
Yeah, pair teaching.
Yeah, this is a new experience for us as well.
Oh yeah, and you have to type in the things. Well, also you could explain, but maybe we can try this, and then if it's annoying for the students, please.
Let's have a little bit of fun. Why not?
Yeah. So we could start by the example of importing the math module that we have already seen before. So import math. And when we do this, we get all the functions available for us in the math module. For example, the square root. So math.sqrt function, and then we give a parameter, for example, 144. And when you run that, then we use this function from math module with this specific parameter. So same thing as we did with the temp converter function. And then there's this nicely formatted info box, which there, maybe Dave, you can open the link from there. So as you can see, math is a module that is available from the kind of Python standard library. And then there are also these, but we had to import math in order to use functions from the math module. While then there are also these built-in functions in Python, for example, print, that we are familiar with, and everything else listed on this page, which we don't even need to import, and they are readily available. Maybe, Dave, you could press on any, which is at the start, which is quite a useful function I've used later on with pandas. And you can see that this function, for example, checks if any item in a list is true, then it returns true. So here you can see the function definition for any. So good to know that there are these built-in functions, and the names of these functions are reserved. So better not to define functions with the same names as these built-in functions. We can go back to the lesson, I think. Okay, and as we saw before, just as a repetition, so we can also, while importing a module, we can give it a new name. So we could, for example, import math as M. And then we could do again m dot function name to access or call a specific function in this math module. And if you check the type, now we have kind of in the namespace, we have this variable m, and what is that? So it is then actually a module, the type of this variable, and we can, by referring to that, we can access the math module. So maybe with math, it's not so useful or even wise to rename it, because math is already quite short, but later on in the course, we'll be using pandas, and it's a custom to import pandas as PD, and then we can access the pandas functions and objects using PD dot then function name. And we'll start using this module next week. Then a bit same way that Dave did just now in the functions lesson, so we can import the single function to be available in our instance. So if we do from module name import function name, so from math import square root. So after importing square root from math, we can then call the square root function directly without having to type in the module name dot function name. So this can be handy, and maybe those who are using R might be maybe more keen to do like this, but it's good to kind of know what you are doing, because then while doing this, you lose the connection between what module is this square root function related to, and different modules might have functions that have identical names. So then things might get messed up. But if you have some very specific functions you defined yourself, it's totally okay to do this from module import functions or variables. So it depends on the case when this is a good practice or not. Okay, then moving on, we can also import only sub-modules. So later on in this course, we'll be using the matplotlib library, I would rather call it. Maybe Dave can quickly show the documentation page of matplotlib from there. So matplotlib is kind of this huge library with like massive capabilities for plotting, doing everything you can imagine with plotting data, graphs. It's also, we use it in the background when plotting maps as well. And then you can find the documentation for each sub-module, each function on the web pages. And there is this module called PyPlot that just went in there that we use for basic plotting. And it's, in this case, for example, it's wise not to import matplotlib with all the capabilities into our memory, but we only want to import PyPlot. And the custom way to do this is to import matplotlib.pyplot as PLT. So import kind of package name dot module name as alternative name. And after that, then we can call different functionalities in there. I had planned to kind of show a simple, if you do a plt.plot and then give two lists, 1, 2, 3, 4, 5, we can make a quick plot just as a teaser. Maybe 3, 2, 1, something like this. So then we can get a descending slope or something more funny. Let's see what kind of plot we get by this XY plot. Okay, so you see already that with this submodule.plot function, we give some parameters, x-axis, y-axis values, and then the style of the line. So obviously you would need to go to the documentation of this module to know what kind of parameters it eats. Okay, but more about plotting in week 7. So then often the question is that then how do you know all the functions available in a specific module, as there's like tons of them. So there are a few ways to get this information. So you can run that cell which says print dir math. So we print kind of the directory or the list of contents in a way of this module, but this is not so informative. Maybe as a quick check, it can be useful. In Jupyter Lab and in other developing environments, you can often then access a list of the available functions visually. So if you start typing in the module name and then press, tab key on your keyboard, so then you get a list and you can scroll down. And if you already typed in the first letter of the function, you maybe, was it square root, sqrt, what was it? So then you can kind of check it and then autofill the name of the function. So that's one way of figuring out what was the exact function name or variable name. Okay, and then same way as with our temp converter, and nice that Dave already showed the docstring. So if we now would want to know what does this math.syn do, so we can call the built-in help function, give math.syn as parameter, run that. So then we get, it's quite short and concise. So we get help on built-in function syn in module math. So syn takes this input parameter and then returns this, how do you pronounce it, sign of x in radians. So technically the math.syn function has a docstring that contains this information. And similarly, if you define your own functions, it's good practice to always include at least a one-liner docstring. If you have a more complicated function, then include a bit more information in there. All right, so then what not to do? So there are things that work, but are maybe not so wise to do. So if we have, for example, let's take this matplotlib or even math module name or package name. So it's not such a good idea to write the syntax from module name import star. So what this would do is that it would import all the modules from this, from all the functions from this module without reference to the module name. And then again, there might be overlaps with built-in function names or so on. So it's kind of good to be in control that from which module am I using which function. So either from X import function name, like specific function names, or then import the whole module and in that case, you would then call module name dot function name. And again, as a repetition, so maybe a good rule of thumb is to use these import module name as something, for example, import pandas as PD, import numpy as NP, import geopandas as GPD, if it's the common practice you see online. Or then if you create your own functions, you can give them nice short names. Yes, and if not, then maybe good to import the full module name. And for example, then with this similarly named modules, so if we would import matplotlib as math, so that would, like, Python won't give you a syntax error, but then you'll end up in trouble, because then if you also want to use the math module, then things get mixed. So there are some of these things that might work, but are not the best practice to do. And PEP, well, there's some points in PEP about importing modules and such, and maybe the most important thing is that it's good practice to always import modules at the top of the file. And this instruction basically applies mostly to script files, so these py files, and your module could also start with importing additional modules. In these kind of Jupyter notebooks, and especially during these lessons, we might, of course, import modules in the middle of the workflow. But maybe in terms of especially your final exercise, and if you have like a clearly defined project, it's good practice to have the module imports as the very first thing at the top, because if there's then some installations that need to be done or some updates, then that's kind of clearly stated at the beginning that which modules this piece of scripts relies on. Okay. Then final thing, this is extra. As mentioned, for this course, you don't have to install anything, but it's maybe a good thing to be aware of the tools that are behind installing Python packages. So for this course, we recommend using the Conda package management system that is then related to the Anaconda distribution and Miniconda distribution. And maybe, I don't know if Dave, you would want to open up a terminal window and run this conda list command. Students, you don't need to do this, just to demonstrate. So how do you know what modules are actually installed in this computer? So then you can run this conda list command, and it will print out a list of modules that are installed, and you can see that there's a bunch of them. So there are many dependencies, and our CSC notebooks also has modules that are related to the Jupyter Lab. But then, for instance, you might see then pandas installed that we will use next week. You will see matplotlib installed. You see the version of the package or module, and you then see the channel, conda channel. So these are kind of important pieces of information that might be then useful later on if you have some conflicts with packages, or if some package has been updated and your code doesn't work with some version of a package. So this is just for you to know where to check if you are missing some module. And we have on the course web pages, we have instructions on how to install Python with Conda tools on your own computer and also the Jupyter Lab instance. So those of you want to install these tools and learn how to do that, you're free to go there and do the installations. But as mentioned, this course can be completed only using CSC notebooks and Binder. So we won't go into details with that. Maybe still one kind of advanced point about installation. So there is also another installer tool that's commonly used for installing Python packages, which is called pip. So pip and Conda are similar, but a bit different. And the rule of thumb there is that if possible, try to use either or. And for this course, we recommend using Conda. The main difference is that pip installs packages from the Python package index, which only has Python-based modules, while Conda is able to install also tools that are written maybe in C, and Conda is maybe better in kind of managing conflicts between packages. So that's something you might run into if you start installing things on your own machine, especially if coding for several years. So these tools are developed, and then you might need to update your tools, and then one package was updated and the other one wasn't, and there might be some incompatibilities. But Conda is an excellent tool then for managing these kind of environments that work with a specific project. Yeah, and indeed you can also, in the Jupyter Notebook, you can list all available modules, but that's a bit cumbersome, so I don't recommend running that cell there. But yeah, so running the Conda list command is maybe the easier way to figure out what modules are available in this environment, which is then related to the kernel that we are using in this file. Okay, so that's just for your information. Maybe for the experience of the people watching, I could pass it over to Dave if you want to continue with the good coding practices. And if you have any questions about packages, modules, Python installations, feel free to ask. So we encourage you to install the things if you are keen to, but you definitely don't have to install anything during this course.
Yeah, thanks, Volko, for the overview of the module system. And yeah, exactly as said, you can see just from looking at the list of modules here how many different things are available directly in Python. And this is one of the reasons why it's fun to teach, because there are so many different possibilities of things you can just pick up and readily use. Regarding this good coding practice for this week, I will keep this very brief because we are needing a little bit of time to introduce the exercise as well. And all I will say here is that you're welcome to read through this good coding practice about writing our scripts the right way. This is really targeted more towards script files than Jupyter notebooks, so it's not something that we need to emphasize so much in here, but there are some ideas that come here that relate to also things you might use in a Jupyter notebook, such as including inline comments. We've already seen these inline comments where you have a pound sign or number sign or hashtag sign, whatever you call this character, at the start of a line or somewhere within the line, and then the text after that is just not going to be executed. But you can also use things like spaces between lines to make your code more readable. So this is the same code that was written here, just with some extra line breaks, and it's clearly more readable. We talked a little bit about docstrings. There's more information about docstrings that you can find in the description of this good coding practice, as well as information about, like, for instance, adding a license. So there may be some instances where within the docstring you want to include a license that describes the conditions under which your software is to be used, or conditions that might limit the use of the software. And so you can do that as well. And finally, there's something here about starting with a shebang. So that has to do with this hash and then exclamation mark at the start of the first line of a Python program that basically allows the computer it's running on to know something about how the program should be executed. And you can read more information about that on the Good Coding Practice, as well as there's a bit about the shebang idea on Wikipedia as well for some basic info there. I think that's all I'm going to say about that, but have a look. It's useful to see some of the elements of how you can write a script file in a format that is easy for you and other users to read and understand. So I think I'm going to already pass it back to you, Vuoko. Maybe I will again let my screen be the screen that is it's still shared. And so I'll stop my video and then open up the exercise for today. So I will do that, and then I will mute myself here in just a second. I guess it's okay to see the exercise on the GitHub version?
Yeah, go for it. So do accept the GitHub Classroom assignment, get your personal copy, and I'll just briefly explain what this exercise is about. So it's again 10 points. Deadline would be by the start of the next lesson. I think like work-wise, this is as big as exercise 3 or maybe even a bit shorter. And we will continue to work in pairs as discussed. So basically we have this week, there's 3 problems, but then we have problem 0. We would very much like to hear some more general midterm course feedback from you guys. So there's a link to an e-form in the README file. We're asking a lot of feedback, but especially this year that we are not seeing you in person. So this is very, very valuable already during the course to hear how you're doing. And we have added some specific questions about these different elements we are using in the online teaching. Maybe we can then improve based on this feedback already in the next weeks and especially then next years. So we highly appreciate any kind of feedback from there. And then these 3 problems, basically they are all related to each other. So in the first problem, we asked you to define, basically you will repeat exactly the same thing as Dave showed you in the lesson, but with bit different settings. So you will define a function that will then convert temperatures from Fahrenheit to Celsius, and that's it. And then you will define your code, remove this not implemented error exception, and then test your function with some values. And again, we have some visible tests to help you solve this problem. So if these code cells don't give any error, your function is doing what it's supposed to do. And we have some questions then at the end. You can discuss these with your partner and then write down your answers. Make sure you have added comments and so on. Then in problem 2, you will get to reuse some code, which is always the smart thing to do when coding. So last week, we did this kind of classification scheme for temperatures. So now you'll get to take that code, do check that it's correct, but you can basically copy paste your own stuff and put it into a function that would then classify temperatures based on the input values. And then again, you should always, after writing the function, test that it works in a logical way. And again, we have some tests that will help you to check that your solution is doing what it's supposed to do, and then the questions. And then finally, the third problem. So you will take the code what you did in problems 1 and 2 and put it into a script file. So again, you repeat the same thing as in the lesson, but then with these functions you have defined yourself. So you'll need to create the script file. Also remember to commit the script file to GitHub, and then you'll import it to this notebook and use it and test. Yeah, so that's it. Do go to the exercise sessions, ask on Slack. And indeed, if there's somebody who hasn't been able to contact their partner, please contact either me or Dave, or then the assistant that is grading your exercises. So we'll discuss how to figure it out. So yeah, do you have any questions? Can't see any in the chat. Yeah, if not, then have fun with writing your own functions. And next week we'll start using this pandas library for data analysis and start actually interacting with data files. So importing data, exploring it, and doing a bit of data analysis.
Yeah, and I just, sorry, would like to, say, good luck with this, with the functions. I hope that that you're able to make some progress through the exercise and maybe clarify some of the ideas about functions along the way. I did want to say one last thing about the course webpage. There have been a couple people who have very kindly noted some typos on the page using the system we have here, where if you see a typo on one of the pages, you can click this edit this page button, and then you can make a note of a typo. And we certainly very much appreciate that. And if you happen to see anything else in looking through the lesson 4 materials, please let us know. And you're more than welcome to click on the edit this page button, go somewhere in here and make a change, and then you'll be given the option, rather than committing the change itself, to fork or create a new branch and commit that and start a pull request. So you'll have this option here actually to create a new branch with whatever your change is in there. And it's very helpful for us to have extra eyes on these materials, as we maybe have started to have a bit of fatigue in our own eyes in reading over the course materials. So your eyes certainly catch things that we have overlooked, and very much appreciate the feedback that's been given so far. Otherwise, I think that's it for this week, unless Vuokko has anything else. And yeah, thanks. It looks like it should be a very nice day. So hopefully you can spend 5 minutes outside in addition to thinking about functions.
Exactly. Okay, see you guys next week.
Yeah, bye. See you next week.